Right, today's case study is a 2013 Chevy Cruze. This has a customer concern of a check engine light and rough driving. So it's got an LUV engine code with the 1.4. That information is found in the RPO code sticker that's in the glove box. It'll say LUV. So we'll select that option. It's asking us where the connectors for the PCM are mounted. Looking at the PCM, they're mounted on the face of it. So we'll go ahead and select face mounted connectors. Now, selecting all these options correctly just leads us to the right section of the scan tool. And of course, this being an aftermarket scan tool, it has all the options available. So it's going to lead through asking us about optional equipment and equipment that's installed so we get all the right data PIDs. Now, once all this information is loaded, we're going to have a couple options to choose from. We have a section of going to diagnosis, hot function, and vehicle profile. Now we're going to go to diagnosis, and then we're going to go to auto scan so we can view all of the codes on the system. So the PCM has 3 codes listed. If we select that, we're going to go in and we see we have a couple options for seeing information in the PCM, viewing special functions, live data. We're going to go to trouble codes. And we'll see that we actually have more than 3 codes that were initially identified. We actually have a manifold absolute pressure, we have a fuel trim system lean, an engine misfire, which is our only code that's not a history code, and an intake air system performance code. Now, these are all pretty common codes to see with the pattern failure that's on this vehicle, as the valve covers tend to have the PCV valve rupture. So we go into live data, and we're going to go down to the fuel trim data specifically. It's broken up into sections for you. And we see as soon as we start the car that our short-term fuel trim starts to climb, and our long-term fuel trim is almost maxed out. I believe it maxes itself out at about 35 or 36. And we kind of know right away that most likely this thing's going to need a valve cover because the PCV valve is probably ruptured. And this tends to be pretty common. So once we're graphing the fuel trim data, both long-term and short-term, we'll actually go under the hood and we're going to block off that breathe port to the PCV valve. And we see that our short-term trims are starting to climb closer to 0 now. That's a good indication and a positive indication that this PCV valve is ruptured, as it shouldn't be allowing vacuum to get pulled from the outside air. So that's causing an unauthorized and unmetered amount of air getting into the engine, which is the source of our fuel trims being so far off. So this is a pretty common repeat failure on this vehicle. Now, what I don't see a lot of technicians talking about is the information that's available to us from GM. So if we scroll down this preliminary information report, it outlines the specific failure that we're having. It also goes farther to outline not only what the failure was, why it's happening. So you'll see that it indicates you to pull this hose off the back of the intake manifold, and that comes from the turbocharger. See, it asks you to pull this hose off right back there on the intake manifold, and there's a spring little metal clip that you depress to pull up on the hose. It's got an O-ring that seals it. We scroll down, we see that it identifies a little small rubber valve that can be seen through that hole. It's telling you need to look for this valve, as that's a valve that prevents boost pressure during events where you would create boost from entering the valve cover and creating pressure against the back of the PCV valve. That's what causes these PCV valves to rupture inside the intake manifold. It goes on to show you a pretty good picture of that valve with a close-up there. It says you should pull the intake manifold off and inspect it. Now, normally you can see this condition without pulling the intake manifold, but this is the root cause of this issue. So we're going to pull that hose off of our intake manifold and take a look. And we can see that we are missing the red valve. So the repair for this vehicle will be to replace the intake manifold assembly and replace the valve cover assembly. If we replace only the valve cover, we've replaced just a symptom, and it's going to return, and we'll be continually replacing valve covers on these engines. The intake manifold has an updated design valve that solves this issue permanently.